Okay, in this problem we're looking at problem number 4, ramp voltage across to a capacitor and resistor. So first step, write down what the voltage is in S space. Well, it's 100 millivolts, which is 0.1 volts, so that's 0.1 over S squared, over the impedance, which is 10,000 plus 1 over 30 times 10 to the minus 9 S. So that will give us, not, what am I saying, this is ES, this is IS. So now it's just a case of tidying up. Let's see if we can make it a little bit more straightforward this time. So 0.1 over S squared into 10,000 plus 1 over 30 times 10 to the minus 9 S. So multiplying out the bracket at the bottom, this will give us 0.1 over 10,000 S squared plus S over 30 times 10 to the minus 9. This equals, if we bring the S outside the brackets at the bottom, 0.1 over S into 10,000 S plus 1 over 30 times 10 to the minus 9. Minus 9. If we work out what 1 over 30 times 10 to the minus 9 is, that might help us to make it look a little bit more straightforward. So this equals 0.1 over S into 10,000 S plus 33.3 times 10 to the 6. So I would now, might be useful too, because eventually we want this S to be just one lot of S, so let's get rid of this 10,000 by dividing each term top and bottom by 10,000, which will help in the long run. So if I divide 0.1 by 10,000, I will get 10 times 10 to the minus 6 over S into just now S plus, and then 33.3 times 10 to the 6 divided by 10,000 is 33.3 times 10 to the 2, which we can write as 3,330. So this equals 10 times 10 to the minus 6 over S into S plus 3,333, which is probably easier to deal with in the long run. So carrying on from there, remember now this is a term for I in S space. We can then divide this up and use partial fractions to come up with an expression for IS. So let 10 times 10 to the minus 6 equal A over S plus B over S plus 3,333. So cross multiplying and then equating coefficients, we get 10 times 10 to the minus 6 equals A S plus 3,333 plus BS. Of course, at this stage here, I should have had over S plus 3,333. So now we can multiply these brackets on the right hand side. We get AS plus 3,333, A plus BS. Collecting terms for FS. So we get A plus B S plus 3333A equals 10 times 10 to the minus 6. So now we can say that A plus B equals 0, and we can find out what, and that 3333A equals 10 times 10 to the minus 6, and calculate A and B. And this gives that A equals 3 times 10 to the minus 9, and B equals minus 3 times 10 to the minus 9. Now we can put these back into the original expression and come up for a value for an expression for IS, which gives this for IS, and then we can use the Laplace transforms, page 5, to get back to an expression for the current in time. And this will give us this: IT equals 3 times 10 to the minus 9 minus 3 times 10 to the minus 9 e to the power minus 333t. Taking the 3 times 10 to the minus 9 outside of bracket, again we get this familiar exponential rise to a limit. And we should be able to predict what that will look like on autograph. We'll get the exponential rise to a limit, and the limit is going to be 3 times 10 to the minus 9 amps. And if we plot it on autograph, you should be able to find out roughly how long it will take this circuit to settle down to its steady state. And this large value for the constant in here, 3,333, means it will probably do that reasonably quickly.